Fine. So 13, 14 people are there. Shall we start? Okay. People are slowly joining. At least 30 should be there in the class, right? For me to start the class. 27. Oh, Rakesh. Rakesh has joined today. Okay, 31. Let me start. Half the class is there. Fine. So, what were we discussing in previous class? Pruning, deleting the unwanted branches, the significance of that, and how to deal with the decision trees with the very large training data sets, where you can have two techniques like rainforest and both. Okay, so these were the things what we had discussed. Then we started looking into the second type of classification technique, which is nothing but a probabilistic learning technique, which is based on what is called your Bayes theorem. Bayes theorem. Okay, fine. So then, okay, I just wanted to see the strength also in between, right? Okay, 37. Okay, so yeah, probably we discussed about two probabilistic learning techniques. That is, what is a probability model and what is a deterministic model. I told you the difference between these two. Then we looked into the three kinds of probability, or the three principles on which the Bayes theorem works. The first is nothing but the prior probability, what is actually originally believed. Then likelihood probability of having in a specific class or category. Or then the last one is what is called posterior probability, which is also called conditional probability, which is the sum of prior probability and likelihood probability. Okay, so Bayes theorem works on these three kinds of probabilities. Okay, so now in today's class, let's see how the classification happens using Bayes model. Okay, so please make a note of certain things rather than just simply sitting and listening or not listening. Okay, please make a note of certain things. It's actually very interesting. So this is the foundation, and all these things are the foundation for your so-called data science or machine learning, which all is a subset of your artificial intelligence. Okay, so all these are machine learning techniques, machine learning techniques or data science, whatever you are learning here in data mining. Okay, so yesterday also I said there are two techniques or which fall under Bayes, which makes use of your Bayes principles. One is what is called your naive Bayesian classifier, and the second one is what is called the Bayesian belief network. Okay, so as far as part of your syllabus is concerned, we will be discussing about naive Bayes classification. Naive Bayes classification model, which works on the principle of Bayes theorem. Okay, so Bayes rule is actually a mathematical formula which is used to determine the posterior probability. Okay, so when you are given the prior probabilities of the events, yesterday I had discussed about all these prior probability, what is posterior probability and other things. Okay, so the calculation is, it's based on the calculation of posterior probability, and it is stated as P of hypothesis by evidence. Okay, so where the hypothesis H, is the target class to be classified, and evidence E is the given test instance. Okay, so based on that, we have what is called the Bayes theorem, which is stated as follows. Okay, so probability of your hypothesis given the evidence, how it is. Okay, so you can, of course, I have put all what each stands for here, but I feel from this you can get a better understanding. Okay, hypothesis by hypothesis given the evidence, is equal to the probability of evidence given the hypothesis into multiplied by your likelihood probability. Likelihood probability. Okay, so this is what is called your posterior probability. Posterior probability. Of course, this is the reverse of that. This is also posterior probability in reverse, which is called the likelihood probability. And these two, P of H and P of E, this is also prior probability, but then we call it by a special name called marginal probability. Okay, marginal probability. Okay, so this is actually the P of H is the prior probability. Likelihood probability in the sense how probable is the evidence given that hypothesis is true. Okay, so then prior probability, or belief in the hypothesis or the parameters before observing the evidence. Okay, yesterday's class I gave you the example also. What is an example for a prior probability and a posterior probability? Okay, with the example of graduation. Hmm. Okay. Then this is what is called your, this is also prior probability, or what is called your marginal probability, distribution of evidence. Mostly we are not interested in this, as this is a constant term. Okay. So this is what your Bayes theorem is all about. Okay. So probability of hypothesis given the evidence referred to as posterior probability. Okay, deriving theory out of evidence, conditional probability. Okay, so this is all posterior probability. Another name is conditional probability. Okay, so conditional probability, conditional probability. Okay, so this is what is called your likelihood probability. This is your prior probability, and this is what is called your marginal probability. Okay, so uh, actually this all of you know the Bayes theorem, whatever I have shown here. So that is actually the basic foundation of probability. It is all about the determination of the conditional probability for a particular event. Okay, so when you say conditional probability, okay, so it is nothing but the probability of the occurrence of an event, given that some other event has already occurred. Okay, probability of occurrence of hypothesis, or given that the evidence has happened or evidence is available. Okay, so that's what your Bayes theorem is all about. Okay, so now let's try to understand this Bayes theorem with an example. Okay, so how to go ahead with the classification using the Bayes model. Okay, so Bayes theorem helps in calculating the posterior probability or conditional probability for a number of hypotheses, from which the always the hypothesis with the highest probability can be selected. Okay, so this is the point to be noted, very important aspect. Hypothesis with the highest probability can always be selected. Okay, so how we select that hypothesis with the highest probability? We calculate what is called a most I mean, after few slides we'll come up. One second, it's called, I forgot the name for it. Maximum posteriori hypothesis, maximum a posteriori hypothesis. Okay, so that's what we calculate. Okay, so we calculate what is called a map, which will help us to decide which is the most highest probability, which can be hypothesis, which can be further selected. Okay, so that's what. Okay, now we'll try to understand it with the help of an example. Okay, so let's say, suppose the weather of the day is cloudy. Okay, so now you need to know whether it would rain today, given the cloudiness of the day. Okay, so I want all of you to listen. It is not just for data mining or unit number 3. Okay, so computer science students, many of you will be working in the field of data science and machine learning. Okay, the understanding of machine learning and data science, all these things will not be complete without an understanding of the classification technique which falls under probabilistic learning, the so-called Bayes theorem, naive Bayesian classifier. These are all very, very important aspects. Okay, so please pay attention. Okay, so you need to know whether it would rain today. Okay, so what are you supposed to do? You're supposed to calculate the probability of rainfall, hmm, given the evidence of cloudiness. Okay, so you're supposed to calculate the probability of getting a rainfall, having the evidence of cloudiness. Okay, so now, having understood this, can you tell me what is the posterior probability part of this equation? Or the conditional probability part for this? Hmm? What is the conditional probability part for this particular scenario? Can somebody tell me? Hmm? What is it? P of the conditional probability for this? Probability of rainfall given the evidence of cloud. Means how will I write it? P of, come on. Sharon
P
Varghese?
of R bar cloudiness, rain bar
That's it.
cloudiness.
That's it. Probability,
Rainfall given
yeah,
cloudiness.
that's what. Rainfall given cloudiness. Cloud or
Ma'am,
cloudiness.
there is
That's
a
all.
formula, right? P of A by B
Ah,
is equal to P of A intersection
ah,
P by P of B.
I
Something.
mean, you apply this. This is what you're going to apply. H given E. The same way your what is it, rainfall given cloudiness. Yeah, the solution part, as you said, you can apply the various things of statistics or mathematics, whatever you have learned. Okay, so the posterior part of the equation would be P of rain given clouds. We're finding whether it would rain today. Okay, so that's actually the hypothesis. And the evidence for it is the cloudiness. Okay, so this is actually the posterior probability part for the scenario. Okay, so mm, yeah, that is a posterior probability part of the equation. Okay, so now we are getting some more data. Okay, so suppose we know that 60% of the time rainfall is caused by cloudy weather. Okay, so therefore we have the probability of it being cloudy given the rain. Okay, so that is P of cloud given the rain is equal to probability of evidence by hypothesis. What is the evidence? Evidence is nothing but cloudiness and hypothesis is rain. Okay, so we have some data now. 60% of the time rainfall is caused by cloudy weather. Okay, so this is actually called the backward probability, where E is the evidence of observing the clouds given the probability of rainfall, which is originally our hypothesis. Okay, so now adding some more data, out of all the days, let's say 75% of the days in a month are cloudy. Okay, so this is actually the probability of cloudiness, or P of cloud, you can say. Okay. Also, since this is a rainy month of the year, let's say that it usually rains 50%. In the sense, 15 days out of 30 days it rains. Okay. So with all these, we can compute the probability of hypothesis of rainfall. Okay, of P of rain is equal to 50%. Okay, so that's what. So now, how do we calculate the probability of raining given the cloudy weather? Okay, how do you calculate the probability of rain given the cloudy weather? So with this much information, can you compute how much it would be? Probability of rain given cloud. So this is what you are supposed to compute by making use of Bayes theorem. So what would be the answer? So how this would be done? Probability of rain given the cloud. So that will be equal to probability of cloud given rain into probability of rain divided by probability of cloud, right? So that is as per your Bayes theorem. Okay, so as per your Bayes theorem, when you substitute the various values, you will land up with 0.4. Okay, so this is what you are asked to compute. Okay, so this we do have all the values from the previous two slides I had given. Okay, so see here. Okay, so here, so you get all the values. So you get 40. So the zero point 0.4, which means there is a 40% chance of rainfall given the cloudy weather. Okay, so this is a simple illustration of your Bayes theorem. Okay, so now after understanding your Bayes theorem, now you know what is Bayes theorem meant for computing your conditional probability or posterior probability when you're given certain things. Okay, now let's try to understand your naive Bayes theorem or naive Bayesian classifier. Okay, so this is actually your naive Bayes theorem. It's actually an implementation of the standard theorem, your Bayes theorem, in the context of your machine learning. Machine learning, it's a very powerful supervised learning algorithm that is used for classification. Very, very important. Okay, so the naive Bayesian classification classifier is an extension of your standard Bayes theorem, what we just studied. Okay, so in naive Bayes, what we basically do is we calculate the probability contributed by each and every factor. Okay, the probability contributed by every factor. Okay, so the naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature, in the sense it is independent. Okay, so every pair of feature being classified as independent of each other. Okay, so this is the most important thing. Okay, so that's the most important thing. I mean, it's independent of each other. Okay, so you can even make a note of it. I'll give you an example. Okay, so the most important aspect of your naive Bayes classifier is it assumes the presence of particular feature in a class as unrelated to the presence of other feature, or every pair of feature that is being classified as independent of each other. Okay, so that's what the naive Bayesian theorem tells you. Okay, so now let's try to understand this with a simple example. Okay, so then I'll show you a demonstration in Google Colab. Then we will work out the algorithm as per the statistics and mathematics how it goes. Okay, so that's how I'm planning to go about it. Okay, so please have a look at the slide. What is being written here? So this is the example which we are going to work out. Are you all listening? Hmm? Listening?
Yes, ma'am.
Rakesh is listening. Rakesh. Rakesh comes in only for attendance, is it? Praveen, if you have problem with audio, you can even text in that I'm there in the class, no issues. So these are people who just connect, connect, and they don't find data mining at all interesting at all. Okay, fine. Okay, now let's listening. Okay, that's Praveen. Okay, good Praveen. But I couldn't hear from Rakesh. Rakesh will text at the end, ma'am, I'm present. So today also no attendance for him. Yesterday I marked him absent. Okay. Fine. So today, let's try to understand this naive Bayesian classifier using an example. Okay. So I hope many would have read by now, by the time I was talking in the class. Okay. Suppose that as a data scientist, you are tasked with developing a spam filter. Spam filter. Okay, so you are provided with a list of spam keywords. These are the keywords which can be treated as spam, something which comes with free, discount, full refund, urgent, weight loss, etc. All these can be these are the list of spam with keywords which are being given to you. Okay, so the company you're working for is a product finance company. Okay, therefore some of the vocabulary occurring in the spam mail is used in the mails of your company. Okay, so that's another catch for you. Okay, the vocabulary occurring in the spam mail, you can see what is the thing. I think free, free is coming here also. Then urgent is also coming here. Okay, these two things are coming in both spam and the official emails of the company. Okay, stocks, customers, important. So these are the keywords, vocabularies occurring in the certain things which occur in both the places. Okay, so now, okay, then again you also have the probability of word usage in spam message and company emails. Okay, so the probability of occurrence of free, the word free is 30%, or 0.3%. Discount in spam is 0.15, whereas free is 0.25 in company mail. Okay, so these are the probabilities of word usage. Okay, so in spam and in company mail. Okay, so now suppose you have a message now. You obtain a message. What is a message? Free trials for weight loss program, become members at a discount. Of course you would have come across such things, right? In your email, you would have come across these sort of sentences. Okay, now we have to tell, classify or predict or tell whether this particular message is a spam or a company email or a ham, the sense spam or not spam. Okay, whether this particular message is a spam or a company email. Okay, so for that purpose, you first calculate the probability of the components occurring in the sentence. Okay, so what are the words coming up? One is, I think, free is there, weight loss is there, then discount, right? Discount. Fine. Okay, so these are the words which come across in the both the spam and company emails. Okay, okay, so first let's calculate the probability of components occurrence of these in the sentence. Okay, so free is point in the spam email. Okay, free is zero point 0.4. Okay, it should actually be, okay, let's assume this is zero point 0.4 then. Okay, right. Okay, so free is zero point 0.4, weight loss is 0.25, and discount is 0.15. Okay, so it is 80%. Okay, so when, but at the same, this is for spam, spam email. Okay, but then when you calculate the probability of email from your company, company email, what are the words which come up? I think it's only free which comes up, right? Free, weight is not there, discount is not there, it's only free which comes as a part of the company email, so for which it is 25%. Okay, so for spam it is 80% and company it is 25%. Okay, so the probability of the mail being a spam is much higher than a company email. Okay, because company email it's only 25%, whereas spam it is 80%. Okay, so your naive Bayes classifier selects the outcome of the highest probability, which in this case was the feature of the spam. Okay, so now we call it as naive Bayes. Why do we call it as naive? Okay, why do we call it as naive is because it finds because it assumes the features to be independent of each other. Okay, so the occurrence of certain features or all the features it assumes to be independent of each other. Okay, independent of other features. Okay, they are not dependent. Okay, like if the fruit is identified on the basis of let's say shape, color, or taste, or you say it's red, spherical, if it's the fruit is sweet or slightly sour, then it is being recognized as a apple. Okay, it's being recognized as an apple. Okay, so what I want to tell is each feature whatever you say, it individually contributes to identify that it's an apple. Okay, without depending on each other. Okay, so that's why we call it naive. Okay, naive Bayes, naive Bayesian classifier. Bayes, of course, because it depends on the principle of Bayes theorem, we call it as Bayes. Okay, so that's why the name. Okay, naive because features are assumed to be independent of each other. Okay, so the feature in our example, they were the input words that were present in the sentence. Okay, these were the this was the sentence. So what were the input words for us? It was free, it was weight loss, it was discount as far as we were concerned. Okay, so that were the input words which was present in the sentence. Okay, so now this makes sense. X given C has occurred. Okay, so the conditional independence among all the features gives us the formula whatever is being given here. Okay, so the frequency of occurrence of the features from x1 to xd, okay, 1 to d, okay, 1 to d is calculated based on their relation to the class Cj. Okay, so This is a formula for it, your Bayes theorem, okay, based on the conditional independence. Okay, so along with the prior probability and the probability of occurrence of the event, so we calculate what is called a posterior probability, through which we are able to find the probability of the object belonging to a particular class. Okay, so now let's see how to use this naive Bayes as a classifier. Okay, I hope all of you are listening. Okay, you have the training data set. Okay, so you have some machine learning algorithm out here. It is a naive Bayesian classification algorithm which is being used, which will help us to develop a classifier model. Okay, so with the help of which, when the new data is being fed to it, fed into the classifier, you will be able to make a prediction. Okay, so that's what. Okay, so now let's see how to implement this particular naive Bayesian classifier over a particular data set. Okay, so the data set what I have taken is the PIMA Indian data set. PIMA, you can get it from the UCI machine learning repository or from Kaggle. Okay, so okay, you cannot write here. Okay. Okay, so the data set I have taken is PIMA Indian data set. It's a diabetes data set. Data set. Okay, so this is actually, you can get this data set from the UCI machine learning repository or from Kaggle. Okay, these are the two open source machine learning repositories available. Or I think I have shown you a website where you can download all the data sets. It was supported by our community. Of course, Python and Colab can also make use of it. It's in the form of CSV files. Okay, so you can do that. Okay, so first step. Okay, so this is, I'm going to demonstrate the naive Bayesian classifier for the diabetes data set. Okay, so I first import the necessary libraries, which will help me to implement this naive Bayesian classifier. Okay, so okay, then first step what I do is I load my CSV file which I have downloaded from Kaggle, that is nothing but your PIMA Indian diabetes data set. Okay, so that has been okay, 100%. So now you can see it here. Okay, this is a data set. Okay, you can read the CSV file. You want to print the data, print the content of the data set. Okay, so now you can see it here. Okay, so now, okay, then okay, the next, this is your data set with 767 records and 9 columns, 9 attributes are there. Okay, so this is you're basically trying to divide the data into independent variable and dependent variable. Okay, independent variable is x and dependent variable is y. Okay, so that's what you're basically trying to do. And head and tail will give you the, head will give you the first 5 rows, uh, and tail will give you the last 5 rows from your particular data set. Okay, so this is from the, it's being provided by the Panda library, okay, which has been imported. So okay, then after that what you do is you can basically split the data set into training and testing data. Okay, for training purpose and testing, that is for validation purpose. Okay, so we are basically training our classifier in the sense, in here, out here, it is a naive Bayesian classifier on the training data set. And you're generating, trying to get you are getting I mean predictions from the test data set. Okay, so for that we are basically making use of this train test split. So that's a functionality which is being provided by the sklearn library of Python. Okay, that's what we are trying to do. Okay, so yeah. Okay, so that's what you have done here. Split the data set into training and testing. Testing is for prediction purpose. Fine. So then, yeah, in this particular step, what you do is, uh, like, specifically, we are making use of Gaussian function or Gaussian naive Bayes classifier. Okay. Okay. So it can either be normally distributed or it can be Gaussian. Okay. It assumes the likelihood of features either to be Gaussian or normal. So I'm taking it as I mean, I'm assuming it to be a Gaussian naive Bayes classifier. It's nothing but an extension of your original naive Bayes classifier itself. Okay. So now, after that, using the test data, you are trying to make predictions. Okay. Predictions from the given sample. Okay. You're trying to make predictions from the given sample. And finally, you try to test the accuracy. Okay. You test the accuracy, and you see that 72 point around 73% of the, I mean, 73% of the test cases are being successfully, I mean, it's being predicted successfully. Okay. Or the classifier, your naive Bayesian classifier has predicted 73% of the test cases successfully. Okay. So that's what, I mean, I don't want to spend more than this time, because it's not a J code paper to make you implement it. I just wanted to show you. So those who are interested, maybe I can share the code or link to it. You can work on it. It's a very interesting aspect of machine learning. Okay. So how to use a naive, you can take up a different data set, and train it, test it, check the accuracy, try to make prediction and see how much accurate it is. Make use of the data sets either from Kaggle or from the UCI machine learning repository. Okay. That's what. Has anyone worked in this domain? Don't worry, I'll not ask you any questions. Just out of curiosity, I'm asking, has anyone worked in this particular domain?
Yes, ma'am. Ma'am, I've done it using data cleaning. I've done it in the data cleaning segment where I had a set of data where I cleaned the data using.
Okay, okay, good. So you have done some pre-processing aspects. You have checked pre-processing. Okay,
Yes,
so
ma'am. Yeah,
fine.
using I've demonstrated it in Colab. I was given a set of data and then I did some similar work. Yeah.
Okay, good, good. Okay, so if time permits, we will also do one a mini project sort of a thing. That's just to give you a understanding of what exactly we have discussed in the theory. Okay, this subject would have been much more interesting if there was a lab associated with it, but unfortunately, we don't have. It's a T code paper, so in between, I can just show you some demonstrations. That's all. Okay, so maybe we'll take up a task of. Data cleaning and the various processes involved in knowledge discovery of databases, and then go for some applying one of these techniques. Okay, if possible, we'll take it up. Okay, so now, we have understood how a naive Bayesian classifier works, okay, by through the demonstration. Now coming to the algorithmic part of it, algorithmic part of your naive Bayes classifier. Okay, so now what happens? This is how the algorithm goes. Okay, so um, so what you basically do is, first you need to compute the prior probability of the target class. Okay, then you compute the frequency matrix, and the likelihood probability for each of the given features. Okay, then after that you use Bayes theorem, which is Bayes theorem, to calculate the posterior probability, that is nothing but your conditional probability or probability of all the hypotheses. Then after that you use what is called the maximum a posteriori hypothesis, also called map, to classify the test object to the hypothesis with the highest probability. Okay, so as shown here, the Bayes theorem will help you in calculating the posterior probability for a number of hypotheses, from which the hypothesis with the highest probability can be selected. Okay, so the selection of the most probable hypothesis from a set of hypotheses is formally defined by this particular map, the map that is maximum A posteriori hypothesis. Okay, so now let's look into what basically this is, what your map is, because you are familiar with Bayes theorem, you know how to go ahead with it. But then how to how to use this map, or what is the formula for map which will help you to classify the test object with the highest probability. Okay, so you have a formula for it. Okay, so given a set of candidate hypothesis, okay, so the hypothesis which has the maximum value will be considered as the maximum probable hypothesis, or it is also called most probable hypothesis. Okay, so the most probable hypothesis is called what is called your maximum a posteriori hypothesis, H map. Okay, so Bayes theorem can be used to find the H map. Okay, so you can see here how Bayes theorem is being used to calculate or find out your H map. Okay, so basically that the selection of the most probable or the maximum hypothesis from a set of hypothesis is what is formally being defined as what is called your maximum a posteriori hypothesis. Okay, so you can see here H map, probability of hypothesis H given the evidence. Nothing but a Bayes theorem. Okay, so yeah, this is your probability of evidence given the hypothesis into probability of hypothesis, your prior probability divided by your specific category of prior probability called your marginal probability, that is the probability of your evidence. Okay, so the maximum in that would be selected. Okay, the maximum in that would be selected. Okay, so uh, now you need to work out a problem using the naive Bayes algorithm. Okay, this time I am not going to do, you people are going to do. So daily I will show in the slide, you just I mean see it. Rather than that, I hope you made a note of this. Please make a note of this. Please make a note of this, and then I will have you all made a note of this naive Bayes classification algorithm. Or do you know what are the steps involved in this? Hmm? Do you know what are the steps involved in that? Suveda, do you know? Or have you made a note of it? Suveda,
Ma'am?
have you made a note of the algorithm in your notebook?
Yes, ma'am.
So now we are going to work out.
Base,
Yeah,
priority, prior
yeah,
probability,
yeah,
likelihood,
yeah.
procedures, ma'am.
Yes, computing the prior probability, you know what how it is. You need to compute the prior probability of the target class. Then compute the frequency matrix, the frequency of occurrence of each, and the likelihood probability for each of the given features. Okay, so likelihood probability in the sense how what is the probability of that being in a specific class or category. Okay, then you use the Bayes theorem to calculate the posterior probability, and after that you use the map hypothesis to classify the test object to the hypothesis with the highest probability. Okay, so now this is the problem which is being given to you. Okay, so naive Bayes classification problem. So what is the problem telling you? Assess a student's performance. Assess a student's performance using naive Bayes algorithm with the data set provided here. Okay, so this is a data set provided with 10 tuples or 10 records. You can see here 10 records are given here. Okay, so the task given to you is to predict whether a student gets a job offer or not, whether he will get a job offer or not in his final year of course. In his final year of course. Okay, so you can see here many are getting a job offer: 1, 2, 3, 4, 5, 6, 7. Okay, 7 out of 10 is yes. Okay, 3 out of 10 is no. Okay, so yeah, so you have to predict based on this training data set using you need to assess the student's performance using the naive Bayesian classification algorithm for the data set what is being provided, and finally you should be able to predict whether the student will get a job or not in his final year of course. Is the problem understood to you? Have you understood the problem? Yes or no? Sriram, understood the problem? Aviral? Attendance is still not over. People have gone. Huh? Aviral Patel, have you understood the problem?
Yes, ma'am. Yes, ma'am.
So what can we do first? What can we do first? What could be the first step according to you? Or Sharon will tell me. Sharon Varghese, what could be the
Ma'am,
first step here? What could be the first step here to start
we
with?
have to compute prior probability.
Yeah, you need to compute the prior probability for the target class. Okay. Can the other Sharon tell me which is the target class here? There is one more Sharon in the class, right? Yes or no? Yes, Sharon. Yes, Sharon has vanished from the online class. Sharon is there in the class, right? Okay, let us mark him absent today. So, Kalyan Sundar can tell me which is the target class here? Kalyan Sundar, which is the target class here? Aravind? 17, Aravind. Which is the target class here? Oh God, with all my energy, I taught you one interesting aspect, naive Bayesian classifier. I'm asking you which is the target class, and people are not able to answer. Is that my failure to make you understand, or are you understanding and you don't want to answer? Shreya will answer now. 24 Shreya, which is the target class here?
Java.
That's it. It's so easy, no, Shreya. Then why your friends are not answering? So can you start by the time I take attendance? So you need to compute the prior probability of the target class, then compute the frequency matrix for each of the given features. For each of the features, you need to compute the, frequency matrix, the likelihood probability, use Bayes theorem, then use map to see which is the one with the highest probability, and then based on the result we can make a prediction as to whether the particular student is getting a job offer or not in his final year. Okay, somebody is putting a text message to me. Who's that? Sharon had a mic issue, ma'am. Okay, Sharon, fine, noted. Your issue is noted. Had to join. Okay, job offer. Good, Sharon. So please start doing this. Okay. So be a little more energetic in the class. Have a breakfast and sit for the class. Otherwise, you'll not be able to listen for the class. Start working out the problem by the time I'll take attendance. Anirudh?
Then, ma'am.
Okay. Okay, those who can't answer, you can put it in the chat window. Anirudh is there. Dharani?
Present, ma'am.
Ramharini?
Present, ma'am.
Okay. All my sweet girls are doing the problems, right? Are you doing the problem?
Yes, ma'am.
Okay, please proceed. Kalyan Sundar, no attendance today. Aravind? Aravind also no attendance today. Why something is coming from the chat window? 17 present. Where were you when I called out and asked you a question? Only for attendance I get an answer, reply. You also had mic problem, huh? If you don't know, you tell don't know. Doesn't matter. I don't expect everybody to be knowing everything. But then I need some response. So next time you don't respond, I will not give you attendance. Sharon Varghese is there. Shakti Priya?
Present, ma'am.
Nishok?
Present, ma'am.
Shreya?
Present, ma'am.
Suveda?
Present, ma'am.
Suveda also, I think, no response.
Ma'am, I
No
responded, ma'am.
response. Sorry. I think I mistook you for somebody else. Vishal Bhashyam?
Present, ma'am.
Computed the prior probability?
No, ma'am.
Why?
I will do.
Please open your book. Search for a pen. Start doing. Srimati, M. Srimati. Okay. Nityashri, 37 Nityashri.
Yes, ma'am.
Pranav Ram.
Present, ma'am.
Pranav progressing.
Yes, ma'am.
Started computing the frequency table.
Computing for CGPA, ma'am.
Please. That's how you should. See, you need to compute the frequency matrix for each of the given features. So he has started with CGPA. So similarly, for those who were sleeping and not listening in the class. Srimati S, 46.
Yes, ma'am.
Raja Singh.
Present, ma'am.
Pooja.
Yes, ma'am.
Lavanya. 54. Lavanya is absent. Yesterday also she was absent. Nityashri.
Present, ma'am.
Sriram. Who's this? 60. No, 59 is absent. Sriram is absent. Fine. Satyamohan is there. What about Likita, 27? Likita is present. Okay. Because your name is not put in the order. That's why I call you later. Satyamohan is there. Okay. S. Sharan, 63. Now attendance comes out. When I ask a question, nothing comes out of your mouth, right? Aviral Patel.
Present, ma'am.
Hemavartini. 68. Fine. Ajay.
Ajay, present, ma'am.
I never call out your name, no? Because on all the familiar names, I think I keep calling out. Ajay is doing. How far did you progress?
Ma'am, I'm still doing, ma'am. I'm completing content.
So that is a very general statement, not acceptable. Akshata Saha. Okay. Noted. Karthik Balaji.
Present, ma'am.
Santosh.
Present, ma'am.
Anand Arun. 115. Every alternate day he is absent. Today also he is absent. Okay. 116 Rahul. Okay, noted. 117 Suhashini Srikanth.
Present, ma'am.
Apurva Ravichandran.
Present, ma'am.
Pithun.
Present, ma'am.
Adityan.
Present, ma'am.
Adityan, what are you doing right now?
Ma'am, interactiveness.
Very good, very good. He's completed CGPA. He has moved on to interactiveness. Good. Okay. Selva Niklesh. Rep is absent today, class representative. Ramcharan.
Present, ma'am.
Achinta Murari.
Present, ma'am.
Santosh Kumar.
Present, ma'am.
Pavitra Shri.
Yes, ma'am.
What are you doing, madam, right now? You sound so desperate. Didn't have breakfast?
Yes,
what are you
ma'am.
doing?
I had interactiveness, ma'am.
Interactiveness. Please proceed. Good. Praveen.
Present, ma'am.
Rakesh. Oh, you came sharp at 9:45 to get attendance. Today also no attendance for you, Rakesh. Unless you respond in the class, you are a person whom I've seen just connects and then vanishes off. Then you come correct in time of attendance. In case I take early, you make it a point to text that you are present in the class at the end to get attendance. I need proper explanation and I would like to hear from you. Only then attendance will come for you. Nityasri Narasimhan.
Present, ma'am.
Nisho Kadiraven. 12. Okay, noted. Abel.
Present, ma'am.
Okay. Preetika. Preetika is there, no? In the class? Yes, yes. Kevin Kurian Joseph.
Present, ma'am.
Hiten. Hiten is absent today. Adya.
Present, ma'am.
Jay Vora.
Yes, ma'am.
Kishore.
Present, ma'am.
Sridevi. Sridevi.
Present, ma'am.
Yash Rai. Yash Rai. Okay, noted. Jayesh Kumar.
Present, ma'am.
Okay. Fine. I think it's time for the next class also. So I think I have not shared the folder for the previous problem also. All these problems would be made into an assignment as far as the third unit is concerned. working out all the 3 decision tree algorithms using one particular problem, all the various techniques plus naive Bayesian algorithm. We have a lot of problems. Okay, so very soon I'll create a folder. You will have to work this out and upload in your folder. Okay, so for this anyway, I will show you the demo. I mean, show you the solution also tomorrow to explain the concepts if you have not understood or the people who are stuck on the way. Okay, so with that, I'm winding up the class. You have any doubts, you can let me know. Thank you.
Mom.
Yeah.
Mom, I joined at 9 o'clock, mom, today.
Then what happened after that?
Mom, after that I was in, mom.